our device is transmitting the signal through the laser to another one, and we can play music through the speaker loudly. And to prove that the music is from the laser light signal, we can just like show the music stop when we block the light from the laser. Actually, the laser is really hard to aim on the. We use a solar cell as a receiver. The laser is really hard to aim on the solar cell, so sometimes the signal does not transfer good because of the position of the laser. And as our final test, we can control the volume of the voice through a potential meter like this, and we can block all of the.
Oh shit! Boston is playing today.
We can block all of the voice right now.
Right.
And also we can transfer the voice from the microphone like this. Hello.
It's not working.
Come closer and please. Hi, hello. We can transfer the voice through the speaker right now and from the microphone. 开始了。
That's our voltage divider, and that's the 9-volt battery. We use this circuit to provide the positive 4.5 volt and ground, and also the negative 4.5 volt. And that's two resistors give us the voltage divider, and the op-amp output is ground, and which connect and the positive side of the circuit connect to the give the positive 4.5 volt, and the negative connect to the battery give us a negative 4.5 volt. For this part, I'm going to introduce the transmitter part, which just after the voltage divider. And for this part, first we need to use the aux in and the microphone to as the input signal to. After a circuit, we need the laser to present the two sound to the receiver part. When there's aux in, we need the amplifier, which the gain is 1, and use a potential meter to adjust the volume to connect to the one side of the summer. And for the mic part, that's a circuit that the TA provide us, and the mic's graph is actually DC shifting at a voltage, and then we need to make it center at 0. So we use high pass to clean it, and then after the gain of 10 op-amp, inverting op-amp, we connect to the potential meter. Also need to adjust the volume, and then they connect to another summer, and after the summer we use a bias T, which shifts the center 0 graph to shifting DC, which can activate the laser, and the laser will provide the light constantly, but include a different frequency to provide the music to let the receiver receive it. For now, I'm going to introduce the receiver and the buffer. For that part, it's actually after the solar cell gets the laser pointing light, it will transfer after the circuit and it will provide the sound from the transmitter part. So here's the solar cell. It gets a shifting DC voltage, and then after the high pass filter, it filters a voltage bias. So for now, the graph is centered at 0, and as an AC circuit. And after the op amp, we got the 11 gain. We got the gain of 11. So there's the voltage is already fill the requirement, and now we need to buffer the current. So actually buffer is here. So there's a voltage in, and we use actually 6 buffer, but the 3 buffer is already enough to explain. So after the buffer parallel connecting together, we connect to the speaker, and the speaker will provide the sound. And actually, for all these op amp, we use inverting, but as we using the AC signal, the inverting doesn't really matter about the result. And that's all for our project introduction for the circuit.